So here we have a total power problem. It says calculate and draw the total power triangle with ST, PT, QT, and theta labeled. These terms are what make up the power triangle. This is apparent power. This is real power. This is reactive power. And this is the theta that is inside of the triangle. So let's get to this part. And what I'll say is that anytime that we have one of these problems where we have the powers already given as var, watts, var, you could also be given it in VA is the unit for apparent power. Here's all the units: real power, watts, reactive power, which is volts, amps, right? Volts, amps, reactive. That's how we know it's reactive power. And this can be capacitive or inductive, which means that it would be negative or positive Q. And then this theta of the triangle is in degrees, but note that this is also the theta Z of the circuit or whichever element you're looking at. So if we're looking at the total triangle, then this would be the same as the Z total, that theta would be. But whenever we have these, my suggestion is to mind your P's and Q's. P's and Q's. And what we're going to do is we're going to add those up. And the reason that works is because all of these are a part of complex power. This is complex power. And in the polar format, it is apparent power with the theta angle. And in the rectangular format, it is P plus JQ. So you can see all of these elements are inside of the complex power. And that's really the goal anytime that we're trying to do a total power, is we're trying to actually find the total complex power, and that'll give us everything we need. So I'm just going to go through and label what I know. P is there. I'll call it Q1, or P1 and Q1. Right here, we'll call this Q2. Note that this power factor is 0. That means that FP equals 0. P over S is the equation for power. So that means I know that P2 is also 0. P3 is also 0. Q3. And this is negative because it's capacitive. This is a lagging power factor. That means it's inductive. That means this is positive. Right here, we have 2 is equal to, there's P4. In this power factor, right, that means that if FP is equal to 1, that means that P and S are equal to each other. Therefore, the Q is equal to 0. So Q4 equals 0. Now, all I got to do for my total power is add them up. P1 plus P2 plus P3 plus P4. And that is because that's how we add vectors. So if I'm adding all of my vectors of complex power of each element inside of here has a complex power. You can even say it has a power triangle. But we're going to add up all these vectors, and the way we do that is by just adding these P's and Q's. P1 is 4, P2 was 0, P3 was 0, and P4 was 2, and that comes out to 6 kilowatts. Q total, I can just add them up. Q1 plus Q2 plus Q3 plus Q4. That's equal to 0 plus 6 minus 2 plus 0 gives me 4 kVAR. And I will label this with inductive because I know that this is positive. That means it's inductive. That means that the power triangle looks about like this right here. There is 6 kilowatts, 4 kVAR. If you wanted to be extra clear, you could write inductive here, but the fact that this triangle is going up instead of down tells me that it is inductive. The last two pieces I'm missing are theta and apparent power. Now, you can solve for those using the power factor and 6 squared plus 4 squared and the square root. That still works. For myself, I prefer to just write the complex total power. 6 plus J4 in my calculator. Go from rectangular to polar. And what it'll spit out for me is 7.21 kVA, angle 33.68 degrees. So right here is 7.21 kVA, and this angle is 33.68 degrees. That's the apparent power. That is the real power. That is the reactive power. That is the theta. Okay. What reactive power is needed to bring the source power factor to unity? The source power factor to unity means I want FP to be equal to 1, which also means that I want P to equal S, which also means that I want my sum of all my Q's inside of my circuit to sum to 0. And I want to turn this triangle into a vector where it essentially looks like this, where P and S are the same and the Q is 0. There is no triangle, it's just a line now. So if I had an inductive kVAR, what reactive power is needed? I need 4 kVAR capacitive, or you could say -4 kVAR. It means the same thing. And last step is I want to draw the component that will bring the source power factor to unity. That's another way of saying I want my total load. And since I will be adding a capacitor in up here, I need to do it correct the source or the total load. I will draw my capacitor in parallel with my source or with my total load. Total load being if I had it like this and I had all of my load added up, then I would put in a capacitor. And the reason we put it in parallel is because in real life, it's not just one capacitor, it could be hundreds of capacitors. And if one fails, we don't want the whole circuit to become an open. So we put it in parallel so that if we had lots and lots of capacitors and it failed, our circuit would still flow. Even if this one failed, our circuit would still work. It just wouldn't have as great of a power factor at that point.